Yeah, greetings of the day. In this class, on this day, we are going to study Unit 4, that is structures. So, structures we are going to complete in 2 labs, most probably. So, I hope this will be a good session. So, here very tiny things are there which we are supposed to study and recollect. So, first thing is basics of structures in C. Then structure members, how we are going to access the structure members, accessing structure members, nested structures. Structures also have a structure inside itself. Then we have array of structures, pointers to structures, and we are having how to pass a structure to a function, etc. So all these things we are going to study in this class or in the next class. So then unions is very quite simple, almost similar to structures. Unions are also there. Some differences are there between structures and unions. So we'll study step by step all of them. So let us get back to PPT. Is my voice audible?
Yes, sir.
Yeah,
Yes,
thank
sir.
you. So we are going to start our next unit, that is structures and unions. By understanding the word structure, everyone will get some perspective in the mind. For example, if you concentrate, if you ask to a civil engineer, what do you mean by a structure? Then civil engineer may be saying that a structure means a set of walls, set of columns, set of pillars, etc. Maybe by seeing the plan of that, or the person may say that structure means plan. So coming to C language, we also have the definition of a structure. A structure is collection of related elements. Coming to a civil engineer, a structure means a collection of walls, a collection of floors, collection of roofs, interiors, etc. In similar fashion, a structure is the collection of elements. A structure is a collection of related elements. What kind of elements? Related elements means they are supposed to be related to one another, possibly of different types having a single name, possibly different types having a single name. For example, if you consider a human body is having many different kinds of parts. Maybe we may have sense organs, and the rest you can call as a non-sense organs. Okay, means there is use of every organ in the body, but we are having different kinds. For example, eyes has different work to do, ears has different work to do, skin has different work to do, etc. Hands, legs, whatever you use. So they are all interrelated with a common name called as a human body. Next, if you consider one more example, for example, you are having something called as a book. A book is the name of some object. Now that object will be having number of pages, maybe the name of the author, maybe the price, with different data types. For example, number of pages is the data type is related to number of pages is integer. Coming to the price of the book is a floating point value. Coming to the name of the book or the author of the book, it is a string. Altogether, what we are doing here is we are clubbing or merging different data types into a single component or an element that is called as a structure. That is called as a structure. Let us see the definition once again. A structure is collection of related elements. It is not a single element. If it is a single element, then it is not called as a structure. It must have more than one element in it. Element in the sense, what is the working, what is the data type, what, etc. Okay, so possibly of different types, and it must also be of different data types. Even if you have similar types also, no issue. Having a single name, it has a single name. It is a mechanism for packing data of different types. Specifically, structure was designed to club different types. For example, we are having a polythene cover. If you go to a shop, the shopkeeper is going to give you some products. Now that products may have hard or solid items, may have some liquid items, may have different kinds of items. Everything is kept in that particular polythene bag. Now that is concept of a structure. We have different types of elements. Those elements can be either same or of different type, we are going to pack the data. We are going to pack the data. So it is a mechanism for packing data of different types. The elements in a structure can of the same or different types. Can of the same or different types. However, all elements in the structure should be logically related. They must be logically related. We in the programming language, we are going to always say logical things. There is no physical concept in programming. Everything is logical. So I hope the structure or the definition of the structure is clearly understood. What exactly when we are going to use a structure, whenever we want to group two or more data types or two or more elements of same type. If you want to merge them and give a common name, then it is called as a structure. The best example is a human body. Another example is a book. A book will be having different properties. Different properties. For example, the book will be having a name, the book may have some price, the book may have some number of pages, many other properties are there for book, etc., etc. You can go on filling those etc. Now, if you consider the name of the book, it is a string type. If you consider the price of the book, it is a floating type. If you consider number of pages, it is called as integer type. So if you want to club these three, integer, float, and string all together and give a name called as book, then this is called as a structure. I don't want to keep the data type separately. I want to club the data. I want to have the data in a single space with a common name. Then we are going to use the concept of structures. Is this understood?
Yes, sir.
Yeah. Another example is, suppose if you are having, let us give one more example. Say the next example is a vehicle. A vehicle will have a name, a vehicle will have some price, a vehicle will have some model, a vehicle will have many other attributes. Then we can say vehicle as a structure element, a structure element. Or we can take one more example. For example, student will have a hall ticket number. If you see the hall ticket number is a string because it is also having characters. Then a student will have a name, it is a string. Student will get some marks, that is a integer value. Student will have an average, that is a floating point value. Student is going to pay some fees, that is a floating point value. Now altogether we can call this particular structure as a student structure by giving a common name which is having internally some other properties. So if this kind of situation is there, then we can go with the structure concept. Okay, so let us move to the next slide. What are the advantages that we have using structures in a program? If we use structures in a program, what are the advantages we have? Application programs are easier to read and understand. So first thing is, it is very easy to understand as well as read when you write a program using structures, because you will be having a structure will be having all the different types of properties that particular structure element has, and you are having everything at a particular location. Application programs are less likely to contain logical errors. Okay, so by having a structure, it is said that the logical errors will be reduced. Errors are more easily found. Improved application programming design, because we know what are the properties will be there, we can improve the application program design means before writing the program we are going to draw flow charts, what exactly we are going to do. Okay, application programs are more easily maintained. So using structures we can easily maintain the structure or the programs also. So these are some of the advantages. So in exam, if you get any question, write the definition of a structure or write what define a structure, you can write the advantages also. So in order to fill the pages, you need to write these things. Okay, first you need to write the definition, then advantages, unless you get the question directly to write a program. If you get write a program, then you can directly start the program. If you don't get a question stating to write a program, then you need to write the definition of the structure, then advantages. So these two slides are very important with respect to exam. Okay, so let us move to the next slide. Then this is the structure of, this is the syntax of a structure. Declaration, how you are going to declare a structure. This is how you are going to define a structure. So first thing that we have in a structure is struct struct. Now this struct is a keyword. This struct is a keyword. So we cannot give a variable name or a function name like struct. Okay. So this one is a keyword. Then we are going to give a tag name. Tag name means, for example, if you go to a shopping mall, the products will be there. On that you will be having a tag. That tag will be having the name of that product, then price, etc., etc. There may be a what do you say, some hologram, etc. Okay. So here tag name represents the name of the structure. In other words, the tag name represents the name of the structure. Again here for tag name, same identifier rules are going to carry. The rules of identifier will also carry for tag name. So first one is struct, which is a keyword. Then we are having a tag name. Tag name defines the structure. Tag name defines the structure. In that you are having data type, a member one, data type, a variable two. Many data types you can have, n number of data types you can have. Then at the end you are going to write a semicolon. So this is the syntax of a structure. Syntax of a structure. First struct will be having a keyword followed by the name of the structure called as tag name, followed by opening and closing flower brackets. In between you are going to write only the declaration of the variables. No functions, no methods, nothing. Okay, in C language. If you go to C++, Java, in Java may not be you have structures. In C++ you are having structures, classes, etc. There you can find the difference. Now here we have the keyword followed by the tag name, then data type, variable name or member one, data type, variable name or member two, so on, data type, n data types, then followed by a semicolon. So you have to recollect or you have to mug up this particular semicolon at the end of the structure. Okay. Let us go to the next slide. See here, the struct keyword is used to declare the structure. Tag name is the name of the structure. The structure should end with a semicolon. So these are the three important points. Now, what is this struct? Struct is a keyword available in stdio.h. This is, in other words, is a keyword. Some book says this is a macro, whatever it is available in stdio.h, standard input output.h, header file. So tag name is the name of the structure. The structure should end with a semicolon. So these three are the important points. Example, if you see the structure student, here we are having character name of 10, integer age, float marks. Now all together, this is a structure example of a student. Okay, you can add some more hall ticket number, you can add marks 1, marks 2, marks 3, marks 4, you can add total, you can add average, etc. Okay, so this is one example where we are having different data types. One type is character, element called as name, character, integer, element called as age, float, element called as marks. So these are elements. Marks, age, name are called as elements of a structure called as student. Elements of a structure called as student. Now, how to declare a structure variable? Now, in the previous slide, what we have seen, this is a structure. Structure is a user-defined data type. Now, the new data type that is created is student. Student is having, again, a collection of different types. So, we can say that a structure is a user-defined data type. Using a structure, you can define user-defined data type. So, here, user-defined data type means, again, we are going to mug up or we are going to merge or we are going to make a group or a batch of predefined data types. By adding some data types, you are going to create a new data type, in other words. By adding existing data types, you are going to form a new data type called as student. So how to create an element for this new data type, how to access is the concept. So how to declare the structure variable? The memory is allocated to the member variables of structure when structure variables are declared. Like normal variables, whenever you declare a normal variable integer v, integer n, at the time of that line execution, the memory is allocated. Similarly, whenever the memory is allocated to the member variables of structure when structure variables are declared. Like unlike data types, the same thing. Syntax. Struct, tag name, a variable 1, variable 2, so on. For example, struct student S1, S2. Now here S1 and S2 are called as the variables of type student, struct student. Okay, S1 and S2 are the variables of type struct student. If you write integer A, then A is a variable of type integer. Here struct student S1, S2 means S1 and S2 are variables of type struct student. Struct student is the new data type in this example. Okay, is this clear? How to declare an element, then how to access the elements of a structure. Next one is, for example, here the one more method. See here, one method is you can declare a structure, then here you are not writing anything, just you are keeping a semicolon. Then if that is the case, you can declare the elements like struct student S1 comma S2. This is one method. The second method is, while declaring the structure itself, directly you can write S1 comma S2. In the previous example, we have S1, S2. Here, if you write, then those are the variables. Here also you can declare the variables, or you can declare the variables like this, struct student S1, S2. In two ways, you can declare the variables for structure. Directly, if you keep a semicolon here, in the next line, write structure student S1, S2. Okay. Otherwise, you can write here S1, S2, all are same. So this is how you can declare the elements. For example, the same thing is implemented here. Struct student, character name of 10, integer age, float marks. Here directly we are declaring the variables S1, S2. These are structure variables of type struct student. Next one. So initialization of the structure, how to initialize the values to a structure. Structure tag name, this is the syntax, then structure tag name, structure variable, list of values. For example, struct student, yes, X is going to store in string, that is name, 18.78 in the next variable, whatever it has. Suppose the structure is having only two elements, then in the first element X will be stored, in the second element 18.78 will be stored. We'll see this example. For example, here we are having struct student, character name, integer age, float marks. So we are having three elements, name, age, and marks. Then directly you can create the variable struct student S is equal to Ramu. Ramu will be stored in the place of name. 15 will be stored in the place of age. 520.00 will be stored in the place of marks. So this is one example how to initialize. We have another all the other ways also. If we want to use or initialize the value using printf and scanf, then how to do that? How to access element by element? So that can be performed using a dot operator. For example, S1 dot age. A dot operator is used. So giving values to member variables. How to give or provide the values to a member variable. The member variable of a structure can be accessed or referenced using dot operator. So here this is called as a member variable S1 dot age. So here in the previous slide, what we have done here is we have directly created or initialized S with Ramu 15520. If you want to give directly with S1 S as the variable name, then you need to write S dot name, S dot age, S dot marks. That is what we are specifying in the next slide. That is, using the dot operator, you can provide the values to structure variables. Structure variable dot member variable. Structure variable is S1, S1 dot age, structure variable dot member variable. So this terminology is important. Structure variable dot member variable. For example, we are having a program here, say struct student, character name, integer age, float marks. Then inside the main, we are declaring a structure variable S1, structure student S1, then enter student details, percentages, percentage D, F1, S dot name, S1 dot name, S1 dot age, S1 dot marks. Printf, the student details are the same thing. Here you will be having S1 dot name, S1 dot age, S1 dot marks. So this is one example how to store the data of a student using a structure. Using a structure, you can say, sir, why can't we go with a normal variable like character name, integer age, float marks directly and accept the values and display the values? Why we need this S1 dot extra? So this is one methodology we have. In a complicated or complex applications, doing with structures is much better than with normal variables. okay, where we are going to create a new data type called as student. Struct student S1. Here now struct student is a user defined data type. Okay, so this is the example of a structure student. Is it clear?
Sir,
Just go through the program. Yeah.
sir, always we have to take S1, sir.
Yeah, you can take V1 also. S1, V1, V, all these are identifiers. Whichever qualifies the identifier rules, you can take. Here you can write struct student A. Here you need to write A dot name, A dot age, A dot marks. The rules of identifier are going to work on S1. Here it is the variable name. Variable name should not start with a number. Variable name should not have spaces. Variable name need to start with a alphabet. Variable name should not have spaces. You can use the underscore. All these rules are applicable for a variable. Similarly, here also they are applicable. Any other doubt? Now, let us write a structure program for finding the distance, okay? Or let us add height of a person. Height means what will be there? Can anyone guess? Height of a person?
Feet.
Yeah, feet and inches. Okay, feet and inches. So for example, one person may be 6.1, some person may be 5.5, some person may be 5.8. What is this 5? What is this 7, 8, what, etc. Suppose the person is having the height. Somebody asks, what is your height? My height is 5.8. What is 5? What is 8? Can anyone tell what is 5? 5 is feet, right? And 8 is
8 is in
inch.
inches.
Inches. So we can say that the person is 5 feet and 8 inches. One important thing with respect to this one is somebody is going to say, sir, my height is 5.12. Do we have 5.12?
No.
No. If you have 5.12, then it simply means that it is equal to 6.0. Is that right?
Yes, sir.
Yeah, 5.12 means because we don't have 12, if the user is going to enter 12, then make it as 0, add 1 feet extra. 1 feet extra. So this concept you need to recollect when you are dealing with heights. So whenever somebody says my height is 5.8, you can say that 5.8 means 5 is feet, 8 is inches. So here feet is also an integer value, inch is also an integer value if you divide both of them. 5 separately, 8 separately, 5 is an integer value, 8 is an integer value. Is this concept clear?
Yes, sir.
Yeah, now we are going to accept the height of a person. Then we are going to complicate the program. So now let us open the dev environment. Just a second, let me open dev. Where is dev? Yeah. Just a second, where is my share? New share screen. Whether dev environment is visible?
Yes, sir.
Thank you. Accepting, yeah. Reading and writing height of a person using structures. So this is our intention. So what exactly the structure will be looking like? You will be writing struct, then height, Height, then opening and closing flower bracket. Don't forget to keep a semicolon here. Then you need to write what are the things we have in height. One is feet, another one is inch. So feet is one thing, inch is another one. So feet is an integer, inch is an integer. Is that right? As per our example, 5.8, 5 is a integer value, 8 is a integer value. So we can write here integer feet, integer inch. Now, this is a structure. As per our slide, how to declare the variable of a structure? Just whatever the structure you have, just copy it, then create a variable for that one. So like integer n you are going to create, integer I you are going to create. Similarly, you are going to create a variable for this structure. Then you can write struct height h, for example. Then can we write h dot feet is equal to 8? Then h dot inch is equal to 8. That is, here feet is 5. As per our example, 8 is inch. So how to display this one? Okay, so printf /n height of Ali is %d dot %d. So here first one is h dot feet comma h dot inch. Very simple example, nothing is there. I'm just displaying my height. Okay, height of Ali is %d dot. If you write a dot here, dot will be displayed. If you write a asterisk, asterisk will be displayed. Then %d. The first value is h dot feet will be replaced with %d. The second %d will be replaced with h dot inch. Here already we have assigned what is h dot feet, what is h dot inch. So very simple one. If you write the structure above main, then it is called as a global structure. If you write inside the main, then it is called as a local structure. Like a normal variable, global variable is there, local variable is there. Similarly here, if you declare the structure outside the main, then this can be accessible throughout the program. If you write the structure inside the function, then it is a local structure. It can be executed only within that particular function. So let us execute this program first, then see the difference. So main. Yeah, height of Ali is 5.8. That is what is intended. Okay. So we may say that, sir, can we keep this inside main? Yes. If you keep it outside, then it is called as a global structure. If you write inside the main, then it is called as a local structure. Okay, you can write inside the main also. So how you are going to write inside the main structure, then name of the structure, variable declaration, accessing the elements using a dot operator, then printing the statement using a dot operator. Let us execute. Now we are compiling the code using a local structure. So same output, nothing change. Okay. So we can declare the structure inside the main or outside the main. If you declare inside the main, it is called as a local structure. If you declare the structure outside the main, it is called as a global structure. Is this clear, program?
Yes, sir.
If anybody is having a doubt, you can ask. Better to write the structures outside the main only, such that it is accessible when you are using the concept of functions. So better to write the structures as global structures. If anybody is having a doubt, you can please ask. Otherwise, the programs will be a bit complicated from here onwards. If there is no doubt, let us move to the next one. So let me copy paste the code. What's up? E2. So now let us complicate the things. Now I want to accept using keyboard. Sir, I don't want to specify. Okay. So what we are going to do, we are going to ask these values inside a function. Okay. I'm complicated the things. I'm complicating the things. So sir, let us accept these values inside a function. So can I create a global variable? This is a local variable, right? So I want to create a global variable, then I can write this line after above main, okay, like global variables integer x1. So let us write one function void accept. Here we'll see, I'm complicating the things, just try to understand what exactly is going on. So accept means is going to accept, void print means it is going to print, that's it. Okay. So accept, instead of writing these two, let us send accept the name of the variable h. Can we write like this?
Yes, sir.
Yes. So what we are doing, we are passing the value to a variable. Okay. So instead of writing the accept, let us display it. Now let us only have a function called as display. Let us accept the values first, then let us call the function. So printf /n enter height in feet. Then I want one more height in inches. So scanf percentile d comma. So the name of the variable is h dot feet. Am I correct here? Is there any mistake in this line? Just go through the line. Yeah, here there must be a comma.
No.
Is that only mistake? One more mistake is there.
And
And ampersand. Very good. So we need to write ampersand h dot feet. Then enter height brackets feet. In feet means they are going to enter 5.8 like that. So in order to avoid, thank you. Enter height in bracket inches. Will be specific more. So let us copy this scanf, then h dot inch. Okay. Now we want to pass this to a function display h. Now this is very easy, right? Instead of writing display h, we can print the values directly. Let us remove this concept of display function at all. So let us make that complicated in the next program. So is this clear? Is there any doubt here? Printf scanf. Nothing new, right? Very simple. Only thing is we are writing h dot feet. This is the new thing. So execute, compile and run. So enter height 5 feet 10, 5.10. Okay, 5 is given value and 10 is also given value. Now we can write height is. Now some user may be entering more than this, means the user may enter 5.12. Execute, compile and run. 5 is the feet and 10, no, 12 inches. Whether we have 5.12, no. So these kinds of things you need to handle. How you are handling, let us see in breakout rooms. Okay, the user is going to enter more than 12 inches. You need to make it as 6.0. How you are going to do that, we'll see in breakout rooms. This is one thing to cover. Is this clear? Is there any doubt in the program? We are going step by step. So this is a structure. This structure variable is created called as h. We are going to ask the user to enter in feet, then in inches, then we are displaying that. Nothing more than this. Very simple, straightforward program. Is there any doubt in the program?
No, sir.
Great. So let us make this program a complicated by not printing here. Now I'm just improvising the program, improvising the complications. Just try to answer this question. This one. Display. I want to display which value h. So I'm passing the structure element to the function. If you want to pass h dot inch, h dot feet, then it will be simple. It will be integer comma integer. So here I am writing display. Then here what you are going to write, void display. Now can anyone help me what will be here, because here you are passing h. What is the h? H is structure height. If you write integer h, then here you need to write integer some variable h or a, whatever it is. If it is an integer, you are passing integer value. Here you are writing the data type followed by the variable. Say here we are having a variable called as x. In front of x, what we need to write?
Till again, sir.
Yeah.
Int.
See, if you are passing an integer value, say I have an integer variable, integer x is equal to 50, for example. If we
Like
want to
arguments,
pass
sir.
this, yeah,
Like arguments we will pass, no, sir.
yeah,
Functions.
argument. What is the data type here we need to write? That is what I am asking.
Float.
Struct.
Yes,
Float.
float. Very good. So that answer is one answer is float as of now. Very good. So integer x is equal to 50. If I want to pass in display x, what is that you are going to write here inside the display? X value is an integer value 50. The data type is integer. If you pass display x, here you need to write integer x. Is that right? Here we are passing x. The data type of x is integer. So here you are going to write integer. That is the first point with respect to functions concept. Now here I am writing h, not x. So there is no integer x concept. Now h is being passed. So here you may write x or you may write h, whatever it is. Now what is the data type you are going to write here?
Struct.
Yeah.
Struct will define, no, sir. Struct
Yeah.
H.
Here
Struct
h is struct height. So you need to write this struct height as the data type. Okay. Is this clear?
Yes, sir.
Yes,
Thank
sir.
you. Whether it is clear with everyone? If we
Yes, sir.
pass an integer value here, the data type must be integer. If you pass a structure type variable, then here it must be what is the structure you are passing. Okay, so here, what is this? We want to display. So can we write like this, printf? Now I want to change h from h to x, two different memory locations, two different values. So here we have a memory of main. In this memory, we have a structure called as h. So the name of this structure is h, and in this h we have again two things. The structure is having two things. One is inch, another one is feet. So one is feet, another one is inch. So one is feet, another one is inch. So these are the memory locations. This is the main memory. This is the main memory. Inside the main memory, we are creating a variable called as h. So h is being created. Again, h is having two aspects, feet and inch. H is feet and inch. So one is feet, another one is inch. For example, the user is entering the height in feet as 8 and inch as 6. So we are passing x. Now here we are passing h. H is being passed, then h is means this complete h is we are passing. We are passing h. H is having feet and inch. This is being passed. This is being passed to whom? A memory which is of type display. Now display is having this particular memory, so name of this function is display. Now this display is getting x, so we have one more memory location in this. The name of this memory location is x. Now in this memory location again we have two things, that is feet and inch. Here we'll be having feet, here we'll be having inch. Is this memory clear? Now, whenever you pass h, display of h, what exactly happens? Exactly what happens is this 8 will be copied. This 8 will be copied into this particular feet, and this 6 will be copied into this inch. So you can say h dot feet, you are going to get 8. H dot feet, you are going to get 8. H dot inch, you are going to get 6. Here, if you say x dot feet, what you are going to get? If I say x dot feet, what you are going to get? Is it 8 or 6? Please answer somebody.
Feet means 8.
8.
Feet, which feet?
8.
8, very good. So here you are going to get 8. What about inch? You are going to get 6. Because here, what you are saying here is display of h, you are passing h as an argument. Display of h, this memory location is passed. Now here struct height x. X means one memory location is created, it will be having feet and it will be having inches. Whenever you are passing h as an argument, h dot feet will be copied into x dot feet, h dot inch will be copied into x dot inch. Is this clear?
Yes, sir.
Thank you. If we print here slash n uh, feet is equal to percentage d comma inch is equal to percentage d. Now, first one is I want to print here feet. What I need to write here? I want to display in this place feet that is received through x. What I need to write here?
X dot feet.
X dot
Very
feet.
good. X dot feet. In the next inch, here I want to display INCH equal to, then I want to display the inches. What is here I need to write?
Same, X dot inch.
Very good. X dot inch. Thank you. Very simple, straightforward one. So here we are going to execute and see whether by passing 8 and 6 we are getting 8 and 6 or not. So execute. So I'm giving 8 and 6. You can see here feet is equal to 8, inch is equal to 6. Means this 8 is copied into feet here and this inch is copied into this inch here, 6. So we are getting feet as 8, inch as 6. So we can write here instead of feet and inch, you can write here simply one statement, height is equal to percentage d dot percentage d. Now first percentage d will be replaced with x dot feet. Then after dot operator, here we will be getting percentage d that will be replaced with x dot inch. Now execute, compile and run. So we are giving 8 and 6. So we are getting height is equal to 8.6. Okay. So I hope this program is very clear and understandable. Is it so? Is that so? Please take
Yes,
a
sir.
snapshot of this particular screen. So this is how it is moved when you use a structure element to pass. The next one I'm going to make more complicated. Okay, so first of all, let me copy this program. Let me clear these drawings. Control A, Control C. Now, next one is a little bit complicated. What is that is, we want to pass two heights, we want to add. Okay, we want to pass two heights and we want to add them. Then we want to display. So here, I want to write height h, comma, or you can say height a, comma b, comma c. Okay, so we are having one height called as a, one height called as b, one height called as c. Then we want to accept two heights. Enter height in feet 1, in inch 1. So here we'll be getting a dot feet, then a dot inch. Then we want to accept another height in feet, another height in inch. So this one is 2, this one is 2. So here a will be replaced with b dot inch. Now we want to add feet separately, we want to add inches separately, then we want to print them. So now we want to pass display a, comma b. Now we are taking the values a and b and we are passing to display function, where display function is going to add and display. Okay, so we can call this as add underscore display. So the name of the function is add underscore display. How many we have? We have two elements of type structure, a, comma b. So here the name of the function is add underscore display. So one is structure height x, comma structure, comma struct height y. One is x, another one is y. So we are passing two elements a comma b into add display function. In add display function, we are receiving structure height x, structure height y. Okay. So one new structure we are going to create, structure height z. Now what we are going to do, z dot feet is equal to, what is the formula to add? Can anyone tell me? One is x, another one is y. So what is the formula here? Z dot feet is equal to what?
X dot feet plus Y dot feet.
Very good. X dot feet plus y dot feet. Thank you. Good one. Then similarly, z dot inch is equal to what?
X dot inch plus
Inch
X Y
X
dot
dot inch plus y
Y
dot inch. Great. Now, there is a chance that the inches may increase more than 12. I cannot have 5.12. This is equal to 6.0, right? Now, how to handle this situation? What is the next line? If z dot inch is greater than or equal to 12, what we need to do?
plus 1.
Plus 1. Suppose the
plus.
user has entered something like this. Just to try to understand, the user is entering some values where the resultant is 25 or 35, 5.35. Without knowing what to enter, the user has entered 5.35. Then what happens? Can I write the statement something like this? Z dot feet is equal to z dot feet is equal to z dot feet plus z dot inch by 12. Can I write like this? Z dot inch by 12. Division operation where we are going to get the quotient. So this is one way. Next, what about inch? Z dot inch is equal to z dot inch percentage 12. One is by 12, another one is remainder. Okay, when you divide, the quotient will be added to feet, and whatever is the remainder, that will be added to, that will be kept in inch. If z dot inch is greater than 12, otherwise this is going to be fine. Okay, don't think much. You will understand once you keep on book or on paper. Take the example as 35. Okay, so this is how you are going to get z value, which is going to get calculated. Then let us print the height. Printf slash n height is equal to percentage d dot percentage d comma z dot inch comma z dot feet. Nothing is there. Z dot feet is already calculated here. Feet is
First
calculated.
feet, no, sir.
Yeah.
Z dot feet, comma Z dot inch. In printf, sir. Last.
Yeah, z dot inch. Yeah. Thank you. Very good. Good one. Otherwise, we may get different output. Okay. So let us execute and see this particular code. I hope it has to work. Execute, compile and run. So one example is 5.2 and another one is 6.3. So we are going to get 11.5. 5.2 plus 6.3 is 11.5. So for good. The user has executed something like this. Let us keep a colon to differentiate the output, because you will see 5 is 15. Execute, compile and run. So first one is 5.13, which won't be. What happened? 5.13 we have given. Let's compile 5 and 13. Another one is 5 and 12. Both are wrong. Okay. So what we got? We got 12.1. Is that correct? 5, 5, 10. 13 plus 12,
25.
25. So
2.1. Yes,
25,
sir.
correct? Very good. So this is how you are going to calculate the height, addition of heights. Now we are going to make here instead of printing, we want to return the Z. So can we write directly Control X, return Z? If we write return Z, here void will become what? Struct height. Void will become struct height. Struct height, add display, struct height. So this is return type, this is first argument data type, this is second argument data type. Now when you are returning a structure element, then here also there must be a structure element. So we have created C. So we can write here C is equal to add display A comma B. Now C is having the result. So if we display, so printf /n sum of heights is equal to %d dot %d comma c dot feet comma c dot inch. So c is holding that value. Is there any confusion now? C, we have created struct height ABC. Then here we are taking the values from the user. Then here we are sending the values to display function, add and display function. It is returning the value, that value stored in C. We are printing the C dot feet and C dot inch. Okay. So what exactly is happening in add display A comma B? Here, first of all, it is a return type because we are returning a structure element Z. Z is struct height Z. Struct height Z. That is what we are returning. When we are returning here, its data type must be there because Z data type is struct height. Here you are writing struct height. Okay. Then name of the function, then the argument data type followed by X, argument data type followed by Y. So this is what we are doing inside the structure. We are creating a third variable. Then we are writing Z dot feet is equal to X dot feet plus Y dot feet. Z dot inch is equal to X dot inch plus Y dot inch. If number of inches are more than 12, then you need to add the inches with the quotient value and the remainder will be in Z dot inch. Then return the Z value. So execute, compile and run. So one height is 3.3 and 4.2. So 3.3 plus 4, 7. Then 3 plus 2, 5. 3 plus 4, 7. 3 plus 2, 5. So altogether, this is a program which is making a call to a function, passing the arguments of type structure, returning the value of type structure. Altogether, we have made the complicated function. Is this clear? Step by step we are going. Nothing to worry at all. I hope this is clear, right? Just practice a little bit. You
Yes,
will
sir.
easily understand. So here reading and writing, no, this is adding heights of two different persons using by passing structure to function. So this is the maximum that you can expect with respect to functions in any exam. Next one. So now we are moving to pointers inside the structures. Then we'll stop. What is the time now?
So like in functions, we will have 4 types of the argument with
Yeah,
return type. Like that, we can do 4 types in this also.
I didn't get you. Once again, please.
In functions, will be no sir 4 types with argument and without argument, with return, without.
Yeah,
Like
everything you can do. Yes.
4 types.
Variable, a normal variable is there. In that place, you can keep a structure element.
Okay, so 4 types will possible or not? Ask us in the structure.
Yeah, it is possible. 4 types, it is possible. So let us get back to slide. I hope slide is visible now. So in our program so far, what we have seen is how to create a structure. We have seen what is a global structure, what is a local structure. Then we have seen how to assign the values to structure elements. Then we have taken scanf, how to assign the values. Then we have seen how to print the values. Then we have seen how to print the height of a single person. Then we have seen how to print the heights of 2 persons. Then we have seen inside the function how to pass the argument. There in the function we have displayed the height of a person. Then we have added 2 heights and displayed in the function. Then we have seen how to return the value to the main function also. So altogether these are all the things that we have seen so far. So what is the next slide? Struct student, same thing. Directly you can assign the values and you can print the values directly in a single printf statement. Okay, initializing the values can be done using this way also, and directly you can print using a single printf statement, not an issue. Then array of structures, we'll see this and we'll stop the class. We'll see pointers, tagged arrays in the next lab, otherwise you will get confused. Thank you. The array of structures, how to create array of structures. For example, in a class we are having 60 students. In a college we may be having 1000 students, and how to create or how to handle those students. So array of structures, the structure variables can be declared as arrays in the same way as we declare array of other types. Okay, so let us get back to the dev environment. Let us create one new structure called as book. So what book will be having? Let me remove all this complicated code. Good. Then let me remove this code also. We don't want. Now, struct book. What exactly book will be having? A book will be having number of pages, NOP, number of pages. A book will be having some price. Say the price is float. The book may have some name, character, name of the book, say 100 is the maximum number which we are going to accept. So this is a structure of book. Can we create here B1 comma B2? Yes. If we don't create the variables like this, then you need to create the variables something like this. Struct book B1 comma B2. Either you can declare the elements or variables like this, or directly you can create the elements here. Both are same. Okay, this is one way of declaring the variables of type structure book, or this is another way of declaring the variables of type structure book. So let us take the second method. Okay, and how to accept the values? Can we write b1 dot NOP is equal to 500? Can we write like this?
Yes, sir.
Yes, thank you. Then B1 dot price is equal to 500 rupees 23 paise. Can we write like this?
Same B1 only,
Yes,
sir.
sir.
B2.
Yeah, B1, not B2. I am concentrating only on B1.
You can write, sir.
Yeah, thank you. So third one is very important. So be frank. B1 dot name is equal to SRU. Can we write like this? You said that B1 dot NOP we can take 500, right answer. You said B1 dot price 500.23, right answer. Now my question is this statement correct? Name is of character with 100 and we are accessing the element as B1 dot name equal to SRU. Is this statement right? If it is wrong, what is the right one? So next statement, I want to print these things directly, printf, then /n. then I'm writing nothing more than percentage D, percentage, yes. So percentage D comma, I want to print a comma between these things, then comma B1 dot NOP comma B1 dot price comma B1 dot name. So these things we are going to get as the output. Now, if I compile, I'm saying I'm going to get an error. If I compile, I'm saying that we are going to get an error. Just a second. Okay, so b1.nop, b1.price, b1.name is going to print me. So I'm having issue only with this line. What is the error here? See, when I compile, I'm getting the error. What is the error? Assignment to expression with an array type. So we can't assign a string like this. Already we have seen this. In strings concept, we cannot assign a string like this. In order to assign, what we need to do, we need to make use of a function called as strcpy b1.name comma sru. I hope you recollect now. Do you recollect this concept? Directly you cannot assign a string. You can assign a character, but you cannot assign a string. If you want to do that, you can use string copy function. Let us execute, compile and run. So we got 500, 53687. Sorry, what happened? Whether we wrote percentage D twice? One is integer,
Percentages, sir.
Percentage
another one
yes,
is
sir.
float.
Float.
Yeah, so we need to change D to F. Price is float value. That's why you got some other output. So now let us execute, compile and run. So first one is 500, good. 500.23011. Then SRE. So we got correct out. So you need to use strings. Whenever you get assignment of strings, use strcpy. Don't write equal to directly. So this is one way. Second way, I can directly assign B1 I'm taking here, and B2 we can directly create struct book B2 equal to in. So here we can assign B2 is first value is 1 comma 2 point. See, in the structure we have to follow the same order. First parameter will be number of pages. What is the number of pages? 250 number of pages. Then price is, say, the price of this book is 1200.00 comma, and the name of this book is Thinking in C, for example. So here we should not use single quotes, we need to use double quotes because it is a string. So this is one way of assigning the values. If you print, then you will be getting the output in the same fashion. Let us go to the printf statement. Now instead of B1, let us print B2. B2, B2 and B2. It has nothing to do with arrays concept. Execute, compile and run. So same thing, 1200.0000. 6 digits precision will be there for floating point values. Then thinking in C, that is what we have given. So we got the same output, B1, B2, so on. Is this program clear now? One way of creating the variable is here, and one way of creating the variable and assigning the values is an example here. This is the next one. You can go with printf and scanf. Otherwise, if you are copying a string, whenever you copy a string, you need to use string copy function. Then this is how we are displaying the values. So I hope this is very clear, this program. Is there any doubt in this program? So here the program name is accessing book elements. That's it, nothing more than that. Elements using structure. No functions, no complications. Any doubts? Thank you. Control A, Control C. Where is WhatsApp? So accessing book elements. Now let us accept arrays. Accessing or implementing array of structures. Now, what I want to do is I want to display hours, minutes, and seconds. So, what is the name of the structure? Can I give the name of the structure as time? Time will be having what all the things? Integer, HH, and integer, comma, minutes, comma, seconds. Is that right? For example, this is structure what we are having. Now, the name of the structure is time. It is having elements like HH, MM, and SS. So, one way to create this one is instead of writing struct book, what you are going to write here? Struct
Time.
T. Now, I want to assign the values. How you are going to assign the values? T dot HH is equal to, what is the time now?
11.
11:16.
Struct spelling.
STRUCT. Thank you. So one is 11. Then T dot MM is equal to how many minutes?
16.
16.
16. Thank you. Then
17.
seconds, T dot SS. You can give any seconds. Let us take 50 seconds. Now we want to display this information. Then what we are going to write? D colon, again D colon. This is how a digital watch is going to display, right? So here T dot HH, comma, by the time we may print, the value may change in your watches. T dot MM, then here T dot SES. So let us execute the code, compile and run. Yeah, 11 colon 16 colon 50. This is the time. Okay. So here you can write time. Time is equal to. So execute, compile and run. Time is equal to 11, 16, 50. Okay. So this is how you are going to print for a normal variable, for a single variable. Not implementing array of structures here just to print the time. I think this program is not required, right? Very simple one. Still you require, let me copy and paste. Nothing is there. Now I want to create array of these elements. So you, instead of writing T, can we write T of 100 like a normal array? Yes. Then what we want to do is we want to ask the user how many values you want to enter. So here printf enter how many times you want to enter. Then scanf %d, okay, %d comma %n. Because we are using n, we need to declare it before using, so we are going to write integer n. Then I want to use a loop, so I'm going to use I for I equal to 0, I less than n, I plus plus. Then here we are going to accept hours, minutes, and seconds. Printf /n, enter time of %d comma I. If you want, you can write I plus 1 also, 0 at first. Instead of that, you can go with this one. Then printf /n, enter hours. Then scanf %d, enter hours, then minutes, seconds. Hours, minutes, and seconds, %d, comma, 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 yes. Then we want to print it back. Is our code correct here? Is this for loop correct?
Yes, sir.
Thank you. That's the wrong answer.
T dot H.
Ampersand. Very good. The other person said it right. What is that? T dot HH. Very good. T dot MM. Very good. T dot SS. So one of our friend also said that ampersand is missing there. Okay, ampersand. So this was the error there. Ampersand and ampersand. Good. Great. So now let us display the content back. So printf /n entered times are, then again we are going to use a loop, printf /n, so %d colon %d colon %d comma. So here we are going to write t.hh comma t.mm comma t.ss. Now whether my code is right here, still one big blunder mistake is there which is not being identified by us. Here we are declaring an array. That is a hint for you. So there is a mistake in this scanf. There is a mistake in this printf. We are declaring an array of time. Now tell me where is the mistake. We are saying that we are going to use array of structures. So the name of the program is implementing array of structure. So for that sake, we have created a structure. Then we are accepting the values t.h, t.m, t.ss. Here we are displaying the same thing, t.hh, t.mm, t.ss. Where is the mistake?
Ampersand T of I.
Ampersand T of I, good one. So here we are using a loop and we are using arrays. So this is important, T of I, then T of I, then T of I. Similarly, here also we need to write T of I, and T of I because we are using arrays. Now, is this error free? Our program is error free. Yes, let us execute it. Go on, all the best. So how many times you want to enter? I want to enter only 2 times. That is hours, minutes, seconds. Say 10 hours, space, 15 minutes, space, 56 seconds. Next one is enter time of 2. Then the next time is 20 hours, say 6 minutes, say 13 seconds. So we got 10, 15, 56, 26, 13. We got correct out. And don't forget that you are not supposed to give commas here because we are having hours, comma, minutes, comma. Don't give 20, comma, 6, comma, 13. You are going to get error. Don't give comma. You can give either a space or you can press enter when you are giving the values. So 10, 15, 56, 26, 13. That is what is the output. Got it? So this is how you are going to implement array of structures. So first thing is you are going to declare the structure. Here you are declaring the structure. Then that structure element is created in the form of an array. Then we are accepting how many values here. Then this loop is going to repeat for those many number of times. You are asking just the message is being displayed. Then you are asking for enter hour, minutes, seconds. Then here you are accepting. When you are accepting, don't forget to use t of I.hh, t of I.mm, t of I.ss. Then entered times are T of I.hh, T of I.mm, T of I.ss. Then we are executing the program. Is this program clear? Any doubts here? So if this is clear, let us take a break for 10 minutes. Then after the break, you will be having programs to do in breakout rooms.
Clear. Clear, sir.
Okay. Now, one important thing. Now the strength of this class is 57. I want all the students to be there in the breakout rooms. I'm going to check the time, how much you are spending in Zoom. Then based on that time only, I'm going to give you attendance. If you are there for 60 minutes, you will be getting 1 hour attendance and so on. Okay. I can find that most of you are vanishing from breakout rooms. If you vanish from breakout room, you are the loser, because in the Excel sheet, you are going to get 0 marks. So I hope it is clear now. Take a break for 15 minutes, then we'll come and meet exactly at 11:30. No, 11:40. I'll be sharing the questions and you can do the programs in breakout rooms. Stop recording.